Hey everyone, I'll be going over problem 17b from homework 3, and the problem is you're given a circuit, and of course it's in time domain, and you are to find a transfer function with uh, the VL as your output and VI as your input, and the transfer function, of course, we're going to do that in Laplace domain. So to start the problem, first you would have to write equations, or well, actually you would have to decide how you want to do the problem. I personally like mesh because for me it's easier to do it, and after doing like these problems on MATLAB and just doing by hand, I find it a little easier to do this type of setup in mesh. So let's start by setting up the loops first. So right here is the first loop, which is for I1, and when we convert it into Laplace domain, the inductor would become 2s, because inductor is LdIdt. So times that with the current, which is I1 of s, plus 2 ohms with the difference of the currents from both sides, which would make it I1 minus I2, minus, because you're entering here into the voltage source from this side, would make it negative VI s equals 0. Now, doing some algebra, you can simplify this whole equation a little better and make it so that you have I1 and I2. I think it's better to always go with this format, because given whatever the problem you have, and if it's a little bit difficult problem, you can easily do it using your calculator or any computation device that you're using, such as MATLAB or Wolfram Alpha or Maple. Alright, so continuing with the problem. So once you have this, you would do for the second loop of the problem, which is I2, and of course I'm going clockwise, so you would have your 2 ohm resistor, which is right here, and then times I2 of s plus this inductor right here, which would give you 2s I2 of s plus 2 ohms and the difference of I2 minus I1 equals 0. Once you have this equation, then just make the equation look neat. So bring the I1 on this side, and this way all the subscripts and everything is looking nice. So once you have these both equations, we know that the inductor is in your I2 loop. So what we want to do is somehow get an equation from I2 that we can use that for I1. The reason we want to do that is because in order to find this for the transfer function, which is your VL, you're going to need I2, but since we have I1 as well, we can make I1 equal to I2, and we can do that using the second loop. So in order to do that, we looked at the second loop equation that we did, which is right here, and we set it up for I1. Let me scroll down a little. Okay, that's better. Alright, so what you do with the second equation that we found, you set it up and you solve for I1. After arranging the equation by taking I2, actually I took 2I1 on the other side, so this equation stays the way it is, so it's not negative. Otherwise you can take it over there and cancel the negative, but whatever. So once you have it set up with I1 equal to I2, you just do some algebra. In this case, you have 2 multiplied with I1, so you divide that, take it on the other side, divide it, cancel the 2, and you will be left with s plus 2. Once you have this, you take this and substitute in your equation 1. So where you had I1, you substitute s plus 2 that we found here for I2 of s, and that's what we want to find a transfer function. And you would be left with s plus 2 times 2s plus 2 minus 2i2 of s equals vi of s. Now multiply this all together, and the product now you have with some algebra, you're going to be left with an equation that looks like this. So I2 of s, 2s squared plus 6s plus 2 equals the input voltage in the plus domain, so vi of s. Since we want the equation which for the transfer function that it is output over input, so we bring vi onto this side, divide this by the with the other side, and you would have 1 over 2s squared plus 6s plus 2. Since in the question they tell us that the transfer function is VL, so we know that it is S for the inductance and times I2 of S, which equals VL. So simply to do this, you can replace I2 with VL of S by multiplying your transfer function that you had right here with this, and that would give you S times 2s squared plus 6s plus 2, and that is, I believe, an easier way of solving a circuit problem like that using mesh analysis.